The Manhattan Project by Joshua D. Ocampo, Jackson Bostaine, and Sam Cromer. In early 1939, at the break of World War II, the world's scientific community discovered that Robert Otto Frinsch had learned how to split uranium atoms. This scientific breakthrough terrified the U.S. and other Allied nations, because by splitting an atom, it breaks one of the most powerful forces in physics, which is strong force. This force is what holds an atom's nucleus together. In addition, rumors soon arose of a possibility that the Nazis would use it to create a nuclear bomb.
Soon after these rumors spread throughout the scientific community, Albert Einstein, a Jewish scientist who escaped Nazi Germany, wrote to President Franklin Roosevelt concerning the use of uranium, as well as urged him to develop an atomic research program. 2 years later, President Roosevelt called upon thousands of physicists, scientists, and engineers to develop the world's first atomic weapon. This multinational effort was later codenamed the Manhattan Project.
However, when this program first began, the funds were low and restricted. Nuclear research could only be conducted at a few universities throughout the U.S. Enrico Fermi, a physicist who left fascist Italy, had a breakthrough in December of 1942 when he produced the first controlled nuclear chain reaction at the University of Chicago.
After proving that it is possible to have a controlled nuclear chain reaction, it became much easier to receive funds, which accelerated the project. Assembly plants for the nuclear bomb were built in Oak Ridge, Tennessee, Hanford, Washington, and Los Alamos, New Mexico, which was the main assembly plant. Robert Oppenheimer later became the project scientific director, and under his guidance, the world's first atomic bomb was created.
By the summer of 1945, the stage was set to test the first bomb. The first bomb's code name was the Gadget. At 5:30 a.m. on July 16, 1945, at the Trinity site near Alamogordo, New Mexico, the Gadget was detonated on top of a 100-foot steel tower. After detonation, the mushroom cloud reached 40,000 feet, completely vaporizing the steel tower, and heated the desert sand into glass with a radius of 800 yards. This blast was an equivalent of 20,000 tons of TNT, thus bringing the world into the nuclear age.
After the war in Europe ended, the U.S. was still skeptical of Japan's unconditional surrender. On August 6, 1945, a uranium bomb, codenamed the Little Boy, was detonated over Hiroshima, Japan, killing between 90 to 100,000 people immediately. Giving Japan only a few days to surrender, a second atomic bomb, codenamed the Fat Man, was detonated on August 9th over Nagasaki, Japan. A little under a month later, Japan announced its formal surrender, thus ending World War II.
Where else in the world at that time could thousands of scientists, physicists, and engineers collaborate their findings to achieve a particular goal? Not only did the Manhattan Project produce the world's first atomic bomb, the discovery of liquid thermal diffusion was a method that could enrich uranium at a more efficient rate than previous methods. The research done during the Manhattan Project also had a huge contribution to the development of nuclear energy, nuclear medicine, as well as advancements in nuclear chemistry and physics.